Okay, so as I think I mentioned yesterday, the idea behind today is going to be to learn how to factor quadratics. Specifically, the reason why we're learning how to factor quadratics, if I just type in the first function here, factoring quadratics gives us a really easy way of figuring out what the x-intercepts are. Okay, so in the previous chapter, we went backwards, right? We used FOIL to get from factored form to standard form. But oftentimes factored form actually gives us a lot more information than standard form does. So it actually makes sense to work in factored form a lot of the time because it does help us out quite a lot. Okay, so today is going to be all about how to figure out where these x-intercepts are and how to factor in general. Here's Nathan. Okay. So when factoring quadratics, we have to consider two separate cases. So we consider the case when the leading coefficient is equal to 1. So that's like this graph right here, or this equation right here. And then when the leading coefficient is not equal to 1. So when the leading coefficient is equal to 1, the method that we use is called the sum and product method, and it's fairly straightforward. Okay, so all right, attendance is done. So let's give it a try, and then we can see if we find the pattern here. It's not so bad. So here we're trying to factor x squared minus 2x minus 8. And what I mean by factor is we want to come up with some expression that looks like x minus t times x minus s. That's our ultimate goal when we're trying to factor, right? We're trying to turn something from standard form into factored form, okay? So when we factor using the sum and product method, our first step is to find, now this part's kind of strange. Our first step is to find two numbers that multiply to give the third coefficient. So two numbers that multiply to give -8. And those same two numbers have to add to give the second coefficient. Okay, so they have to add up to -2. So can anyone think of two numbers that multiply to -8 and add to -2? I know it's early. Anyone?
Well, that multiply to get -8, 4.
Yeah, 4 with what?
What do you mean, like 4 times -2 would give you -8?
Exactly. Perfect.
Yeah.
So that's kind of the idea behind what we're doing here, right? However, we have to be a little bit careful, right? Because not only will it multiply to give -8, so you're right, 4 times -2 multiplies to give -8, but they also have to add up to give -2, right?
Yeah, which it does not do. No, it does not do that.
But it's very close though, right? It adds up to give +2. So how could we make it so that those two numbers would add to give -2 instead?
You just switch one of the signs?
Yeah, you flip the signs, exactly, right? So all we have to do would be, instead of having 4 and -2, we have -4 and +2, and that would do the job, right? So in this case, multiplies to 8, or multiplies to -8 is, so -8 is equal to -4 times 2, and adds to give 2, so that's -4 plus 2, right? So we can see -4 and +2, it works out, right? Both of those seem like they satisfy those two criteria there, okay? And so the last step, once we find those two numbers, we can just write the quadratic with the brackets where s and t in the quadratic equation formula in factored form here, s and t are the two numbers that we found in the previous step. So all we do from here is we write x squared minus 2x minus 8 is equal to x minus 4, x plus 2. Done. We've factored. That's it. Okay, so it's a pretty straightforward process. one thing that really helps with this is being good at your like multiplication tables, right? Because it helps to have factors of a certain number in your head really quickly to access in order to determine what these two numbers are. Okay. And so let's just make sure, right? Let's do a quick check that this is actually the correct factored form. Okay. Anyone have an idea of how we might check that this worked out correctly? Okay, well, we could go backwards, right? We could use our FOIL method. We could expand it out to see that we get the original equation, right? So let's try to do that. So let's attempt to FOIL here. So we start with the first terms, then the outer terms, then the inner terms, and then the last terms. So x times x gives me x squared. X times 2 is plus 2x. Negative 4 times x, that's negative 4x. And then negative 4 times 2 is negative 8. And we just collect like terms here. So we get x squared minus 2x minus 8. And that is exactly what we started with, right? We can see that the equation that we started with is the exact same as the equation we ended up with when we expanded this thing out, okay? And that's it. That is factoring via the sum and product method. Does anyone have any questions on the sum and product method? Okay, cool. It's a lot of pattern matching, right? I would say the operation is not too tricky. But yeah, you just have to identify the pattern and then just sort of apply the pattern. It doesn't get much more challenging than that. So let's try another one here. We'll try a handful. Again, this is one of those things that the more you practice, the easier it becomes, right? So I'll try not to keep you too long today, and we'll get lots of practice in. So in this case, we have x squared plus 12x plus 35. And so we are trying to, let's just make sure I'll use the same colors. We're trying to multiply to 35, and we're trying to add to 12, okay? So our goal here is to find two numbers. So number 1, number 2, that multiply to give us 35, and add to give us 12. Can anyone spot those two numbers?
5 and 7.
Yeah, very good. 5 and 7, right? 5 times 7 gives us 35, and 5 plus 7 gives us 12. Excellent. And then from there, we're pretty much done, right? All we have to do after that, once we identify those two numbers, then we just write out our brackets, right? So x plus 5 and x plus 7. And that is equal to our original quadratic. Okay. And so as I mentioned, going back here, I'll type out the new example as well, plus 12x plus 35. So as I mentioned, or as we saw, I guess, in the previous chapter as well, factored form tells us where our x-intercepts will be, right? So we know that from the previous example, considering we have x minus 4 and x plus 2, we know that our x-intercepts would be at positive 4 and negative 2. And we can see that with the red curve here, right? Negative 2 is one of our x-intercepts, and positive 4 is the other one, right? So by factoring, it allows us to actually figure out where the x-intercepts of the parabola are, right? If we just have the equation in standard form, just by looking at that equation, we have no idea where the x-intercepts are. So this is our x-intercept finding method, okay? And let's check out the other one to make sure we got that right. So x squared plus 12x plus 35, negative 7, negative 5 were our x-intercepts, right? So everything looks good here. X-ins are negative 5 and negative 7. Does anyone have any questions about the sum and product method so far? All right, cool. Let's keep it going. So I have a few more examples here. So x squared minus x minus 72. So again, we are trying to multiply to get to negative 72. And we are trying to add to get to negative 1. Any ideas This one's a bit harder. I know that 72, I know the factors of 72, two factors are 8 and 9, right? 8 times 9 gives us 72. And because they have to add up to -1, I'm going to write -9 plus 8 to get to -1. -9 times 8 gets me to 72, -72. And so my two factors here are -9 and 8. And so I just write this as x minus 9, x plus 8. And that's it. So nice and quick. So here, this one, my x-intercepts are 9, positive 9, and -8. All right, let's try another one here. Okay, so we have a squared minus 13a plus 36. So I have to multiply to get to 36. And I have to add to get to -13. Okay. One place, I guess, where this can be tricky is just keeping track of your positives and negatives, right? So in this case, we have to multiply to get a positive number, but we have to add up to get a negative number. So that suggests that both numbers should be negative, right? Because a negative times a negative gives us a positive. And if we add up two negative numbers, then the result will still be negative. Okay, so in this case, seems like 36 is, I mean, 6 times 6 is one option, right? So you might think, okay, well, let's try -6 times -6. Well, that gives us positive 36, so that checks out. But -6 plus -6 is equal to -12, which that one doesn't work out. Okay. So then we try another one. So I also know that 9 and 4 give us a product of 36. So let's try -9 times -4 equals -36, or positive 36. And then -9 plus -4 is -13, which is perfect. That's exactly what we want. So then I have -9 times -4, -9 plus -4. And so my resulting quadratic in factored form is a minus 9, a minus 4. Okay. And then one more example here, one more quick example. Let's try this one. So x squared plus x plus 6. So in this case, we have to multiply to get 6. And we have to add to get 1. Now this one seems kind of interesting. Multiply to get 6, adds to get 1. I don't think I can spot one that works. Let's actually graph it to see what the x-intercepts will be. Because sometimes this doesn't work. So let's see. So what do we notice about this graph? When I go and graph this parabola, what do you guys notice about it?
It doesn't cross the x-axis.
Exactly. Perfect. So this graph does not cross the x-axis. And so in this case, it actually doesn't make sense to factor it, right? You just can't factor it. There is no way to manipulate this to turn it into factored form because there are no x-intercepts, right? It becomes kind of like a meaningless question. So it does not cross the x-axis, therefore we cannot factor. Okay. I'm sure you guys have heard this term before. When a number doesn't have any factors other than itself and 1, we call it a prime number, right? So when we cannot factor something, we say that it's prime, right? So on your worksheet, I'll pull it up right here. On your worksheet, I think it says, or at least I thought it said, maybe not. I might have been looking at another worksheet, maybe this one. Yeah, so like if you can't factor it, write prime, right? So that's the idea behind that. If there's no way to factor something, so in this case we were talking about common factoring, but if you can't factor something, then it's just prime, right? There's no way of reducing it to a factored form, okay? We might also stumble upon situations, let me just I'm guessing at an example here, but so we might also stumble upon a situation where the x-intercepts that we get are some decimal answers, right? So we can see in this case, x squared minus 6x plus 4, we notice that, okay, it does have two x-intercepts, so we should be able to factor it. But what we're noticing with all of the examples that we've done so far, the numbers that we get are integer values, right? They're not decimal numbers. And so when we have a situation like this, where we are going to get decimals as our x-intercepts, we're going to have to use another tool in order to solve this. And that tool is called the quadratic formula. But we're not going to touch that until, so we're in chapter 4 right now. I'm pretty sure chapter 6 is when we cover the quadratic formula. So we will eventually be able to treat these, but we won't be able to do anything with them yet. Okay, so this is still out of our toolbox. We are going to stick with quadratics that we can factor, and when we factor, we get x-intercepts that are integer values. Okay. Any questions so far? Okay, cool. Well, let's try one more example, and then we'll move on to some harder decomposition problems. So one thing that we always have to make sure to do when we're factoring is we should always check to see if we can common factor something first, okay? So here we're given a some sort of degree 3 polynomial, right? Again, I think I mentioned that briefly last chapter, but we didn't do anything with it. I just kind of mentioned it and said, okay, this is more for like a grade 12 topic. We're not going to be focusing on it at all, right? However, we should notice that we can definitely common factor, okay? So this is something from your homework from yesterday, right? So in order to figure out what we can common factor, let's first look at the numbers here. What's the greatest common factor of 3, negative 21, and negative 24? Anyone? Greatest common factor, 3, negative 21, negative 24?
3.
3, yeah, thank you. So 3. And then we also look at the variables, right? So we notice that we have y cubed, y squared, and y. And so each of those contain a y, which means we can also factor out a y. So our greatest common factor is 3y. And so I'm going to factor out a 3y. So this is going to be equal to 3y. And then in the brackets, I'm going to write everything that's left over after I factor those things out. So what's left over, I always like to do this work off to the side. I'll have 3y squared divided by, 3y cubed. 3y cubed divided by 3y. So I can see that my 3's will cancel. I have y cubed divided by y, so I'm just left with y squared. Negative 21y squared over 3y. So negative 21 over 3, that's negative 7. And then I have y squared over y, that's just equal to y, so minus 7y. So y squared minus 7y. And then lastly, I have negative 24y over 3y. So again, my negative 24 and 3, that divides to be negative 8. And then y divided by y, well, those just cancel out, right? So y divided by y, those are gone. And so I'm left with y squared minus 7y minus 8 inside my brackets here. And then looking at this is just a quadratic, right? And I look at the quadratic and I notice also that the leading coefficient is 1. Leading coefficient is 1. Which means I'm allowed to use some in product, right? Sum and product, which is great. So I turned something that looks really challenging, right? Like this 3y cubed minus 21y squared minus 24y. It looks tough, right? Like I don't want to deal with that. That looks like a kind of a pain, right? However, once I common factor, what I'm left with is a nice, easy quadratic to factor, right? Now I just have to find two numbers that multiply to give me -8, and that add to give me -7. Okay. This one's not so bad. I know 8 times 1 will give me 8. So if I make one of them negative, I'll get -8. And in order to add to -7, I'll be making -8, or I'll be making 8 the negative number. So -8 times 1 and -8 plus 1. And both of those will work out quite nicely. Okay. Okay. And so now I just have to finish my process here. So I bring this down again. So this is equal to 3y, and then y minus 8, and then y plus 1. And that's it. I've fully factored this. Okay. Now, just out of curiosity, let's just see what this thing looks like. 3y cubed. Actually, it might get mad at me with my y's instead of x's. I'm gonna have to replace these with x's. Yeah. Minus 24x, there we go. And so this one looks, again, it's not something we've seen before. It's definitely not a parabola. It's some sort of like zigzag kind of graph. Again, we don't have to worry about details here. But if we notice, we actually have, in this case, we have 3 x-intercepts. One of them's at -1, so that kind of makes sense, right? Because I have an x-intercept of -1 here. The other x-intercept is at 8. That makes sense. I have y minus 8 here. Now, when I have something like this y out front, I will also get an x-intercept at 0, right? So I get another x-intercept at 0, and that's where that one comes from. Okay. So this this kind of cool-looking cubic function, this cubic polynomial, will have 3 x-intercepts. But again, we don't have to worry about the details here. We're going to be sticking to quadratics. So this is something that you're going to be seeing for sure in grade 12 if you keep going with math that far. Okay. Okay. Before moving on to something a little bit more challenging, does anyone have any questions about sum and products? Okay. Excellent. Okay, so now let's get into something a little bit more challenging. So when the leading coefficient is not equal to 1, so when there is a value in front of the x squared, so in this case, our leading coefficient is 3, then we can't use sum and product anymore. We have to use something called decomposition, which is a little bit more challenging, okay? We could also use the quadratic formula, and that's what I mentioned previously, but we're going to cover that a little bit later, okay? So we're going to be using the quadratic formula whenever we have to, or whenever we're going to end up getting some sort of decimal x-intercepts, but it can also be used in general, and so we're gonna worry about that in a bit. So yeah, let's give this a try. So when factoring using decomposition, the process is somewhat similar. So we need to find two numbers that multiply to give you the third coefficient times the first coefficient. So slightly different from sum and product, because here we're trying to find two numbers that multiply to give the first coefficient, so 3 times the third coefficient, so 6. So we're trying to find two numbers that multiply to give 18, but then we're still adding to get the middle term, right? So we're still adding to give the second coefficient. So in this case, the second coefficient is 11. So we are adding to get 11. So multiply to 18, so that's 3 times 6, and then add to get 11. That's our goal here. So this one's not so bad, right? Factors of 18, so we have 3 and 6, but that won't work, right? Because 3 and 6 gives us 9, so that doesn't work. 9 and 2, 9 and 2 should work. 9 times 2 results in 18, and then 9 plus 2 results in 11. So that all checks out. Now here's where the differences come about, right? Like that process is pretty much the same as it was for sum and products, but here's where it gets a little bit more challenging. So what we're going to do is we are going to split the second term, so the term with the single x in it, into 2 separate terms using the numbers that we just found. Okay, so I have 3x squared plus 11x plus 6. I'm going to take this middle term and I'm going to rewrite this equation, but I'm going to split the middle term up based on the numbers that I found in the first step. So I'll have 3x squared and then plus 9x plus 2x plus 6. Now, just looking at what I've done here, have I changed the equation at all? Like, have I added anything that wasn't already there, or have I subtracted anything that wasn't already there?
No.
No.
No, exactly. Good. Because all I've done was I've just kind of rewritten it in a different way, right? It's not like I went and did like, I don't know, minus 18, right? I didn't do anything like that. All I did was I rewrote it, splitting up this middle term into 2 terms, but it just adds back to get me the same thing, right? If I were to go backwards, nothing would change, right? I would just collect like terms, I would collect these 2, and I would get 11x back, okay? So the key here is I'm not changing anything. If you find yourself starting to change stuff or adding stuff that wasn't already there, then you're going off on the wrong path, okay? Now what we're going to do, once we've split those 2 terms up, is we are going to group the first 2 terms together and the last 2 terms together, and then we're going to common factor each grouping. So let's make the second 2 terms blue. So we are going to 3x squared plus 9x. So there's our first grouping. And then plus 2x plus 6. There's our second grouping. Okay. And then from each of these groupings, what I'm going to do is I'm going to common factor each grouping separately. Okay. So if I look at the first grouping, the green grouping here, I notice that my greatest common factor is going to be 3x, right? Each term has an x in it, and both 3 and 9 are divisible by 3. So I'm going to factor out a 3x. And when I do that, I'm going to be left with x plus 3. So I've common factored out my first grouping. Now, when I look at the second grouping, not as much to factor here, right? Only one term has an x in it, so I can't common factor an x. But both 2 and 6 are divisible by 2, so I can common factor out a 2. So I'll have 2, and then x plus 3. So I read a note here. So after we common factor, we notice that we have 2 terms that are the same. Right? We have an x plus 3 and an x plus 3. So we have 2 brackets that are identical. If you do not have 2 brackets that are exactly the same, it means you've done something wrong along the way, right? So you have to backtrack to find where your mistake is. Okay, so you will always have 2 brackets that are exactly the same. Now, as we saw yesterday, when we do have 2 brackets that are the same like that, we can common factor. We can common factor that bracket, okay? So if we common factor an x plus 3, then the other bracket is just what's left over, right? So if we look at x plus 3, so that's our pink bracket there, what's left over is the 3x and the 2, right? And so our other bracket is just 3x plus 2. And then we're done, right? We have successfully factored this thing. Let's see if we're right. So, whoa. Can someone erase that? How did someone do this? Annotate, clear all drawings. Thank you. Actually, can we practice this? How neatly can you guys write? Can someone write and like equations here? Okay, so you have to write like pretty big. Can you write like really small, like 3? I guess it's kind of tough with a mouse, eh? Interesting. We might use this. I'll try to find a way to use that. But yeah, I guess without an actual like stylus or something, it might be kind of challenging. I don't know, 3x squared plus, yeah, it's kind of messy. All right, we'll keep an eye on it. Maybe we'll do something with that. Okay, so let's see if we're right. So we have 3x squared plus 11x plus 6. And let's type in our factored form, so x plus 3 and 3x plus 2. And we see that we get the exact same graph, right? They perfectly overlap each other. And so we can tell that we've done a good job here, right? Now let's figure out what our x-intercepts are. So I mean, I could just click on the graph, -3 and -0.667, right? But I just said, oh, wait, hold on, decimal x-intercepts. We're not supposed to be able to get those, right? Yeah, we just got one. So that comes from setting each of these terms equal to 0. So if we set each bracket here equal to 0, so x plus 3 equals 0, if we move the 3 over to the other side, we get x is equal to -3. Similarly, if we set the second bracket equal to 0, so 3x plus 2 equals 0, then if we move the 2 over, so 3x equals -2, or x is equal to -2/3, and that's where we get the -0.6667. So -0.666 repeating. Okay. And so that's where those two x-intercepts come from. Does anyone have any questions about this process?
Can we do another example?
Of course.
Please.
Yes, of course. Okay. Yeah, let's do another example. I think I have 3 more examples, so we're going to get lots of good practice with this. Okay. So let's factor. So here we're trying to factor 4x squared minus 8x minus 5. So again, our job here is to find 2 numbers that multiply to give the first coefficient times the last coefficient, that also add to give the middle coefficient. Okay, so we are trying to multiply to get to 4 times -5. So multiply to get to -20. And we have to add to get to -8. Anyone want to take a stab at those 2 numbers? So when doing this, what I used to do, like especially when I was first getting started with this, is I would do like a little, almost like a little factor tree off to the side here, right? So I think of all the numbers that multiply to give me 20. So 1 and 20, 2 and 10, 3 doesn't work, 4 and 5, that's it, right? And then what I would do is I would look at each pair and I would try to determine, okay, is there a pair that works that will get me the number that I'm trying to add to, right? And indeed, I can see that, oh, wait a second here, 2 and 10 will definitely work, right? But I just have to find the right combination of positives and negatives that will make that work, right? In this case, if I make it +2 and -10, then I'll add to get -8, which is exactly what I want. So in this case, I will have 2 times -10 and 2 plus -10. Okay, and then we go through the decomposition step. So our next step, we're going to take our original quadratic and we are going to split up the middle term into two separate terms based off the numbers that I just found. Okay, so we have 4x squared minus 10x plus 2x minus 5. One thing to note here is that it doesn't matter which order you put those two terms in. Okay, so it doesn't matter if you go negative 10 plus 2x, or if you go 2x plus, minus 10x. It doesn't matter which way you put those. You'll get the same result in the end. Okay. Perfect. So now from here, we do our grouping, right? So we look at the last two terms and the first two terms. And we are going to factor each of those separately, okay? So for our first two terms here, we can common factor, let's see. So 4 and 10 are both divisible by 2, and both of those terms have an x. So we can factor out a 2x. And when we do that, we're going to be left with, so 4x squared divided by 2x, that's going to be 2x. And then negative 10x divided by 2x, that's negative 5, right? And then I do the exact same thing to the last two terms, right? But I look at the last two terms, and I notice maybe a slight issue, right? The last two terms, there isn't anything in common between them, right? 2 only has two factors, right? 2 and 1, and 5 only has two factors, so 1 and 5. So we can't really do anything there. In that case, what I do is I write plus, and then just to make it look like other decomposition questions, I'm going to write this as plus 1 times 2x minus 5. And that plus 1 tells me that I haven't common factored out anything, right? There is nothing to common factor. There is nothing to common factor. Okay. But then from here, the process works exactly the same, right? I recognize that I have two brackets that are exactly the same, which is what I want, right? If I didn't have that, I would have to backtrack to find a mistake. And then from here, what I do is I common factor that bracket, so 2x minus 5. And then the other bracket is just what's left over in each term, right? So in this case, I have 2x and then plus 1, so 2x plus 1. And then I'm done. That's it. Okay. And from here, depending on what the question is, I think some questions will ask, I'm pretty sure some questions will ask, there we go. Sorry, some questions will do like a follow-up question. It'll say like, oh, what is the x-intercepts? What's the vertex? What's the axis of symmetry? Et cetera, et cetera. Yep. And so from here, let me just see. Factor each expression. At least I thought it did. I think there was one question here. It might have been in the previous question. Anyways, it says find a few other properties about the polynomial. So that takes us back to stuff that we did in chapter 3, right? Finding the x-intercepts. Yeah, write the relation in factored form, determine the zeros, determine where the vertex is, and sketch a graph of the relation. So a question like question 13 is really good because it combines kind of everything all into one go. And you have to know everything that we've done so far in factoring, as well as all the properties that you guys had your quiz on Friday. Okay, so question 13 is a great question because it brings everything all together. Okay. All right, how are we doing with decomposition now? A little bit better? Any questions from this example? Cool. I guess we could quickly find the x-intercepts here. So if we set this equal to 0, 2x minus 5 equals 0, 2x equals 5, x equals 5 over 2, or 2.5. So there's one x-intercept, and the other one comes from the other bracket. So again, we set the other bracket to 0, 2x plus 1 equals 0, 2x equals negative 1, x equals negative 1/2, or x equals negative 0.5. And so let's graph this and see that we do get those two x-intercepts. So 4x squared minus 8x minus 5. So we get an x-intercept at negative 0.5 and an x-intercept at 2.5. So we have successfully found our x-intercepts, which is great. Okay, let's try a couple more here, and then I'll point out some little tricks for factoring that will definitely help you out quite a bit. So yeah, let's try this one here. So factor 12x squared minus 25x plus 12. So again, we are looking for two numbers that give us 12 times 12. So two numbers that give us 144. And then they also add to give us negative 25. So two numbers that multiply to give 12 times 12, which is 144. And two numbers that add to give negative 25. Now this is kind of tricky, right? This is an example where I would say having like a little factor tree would definitely be really handy. Now there's some cool tools here. I think if you just do like factors of 144 into Wolfram Alpha, it'll just list all the factors, right? But there's a lot here, right? Like 1 and 144, 2 and 72, 3 and 48, 4 and 36, and so on. It's kind of messy, right? So there is some sense of guessing here, right? I would recommend guessing at a number, seeing if you're correct. If not, kind of return to the drawing board, right? So in this case, let's see what we got. 8 times 16. 8 times 18. Okay, 8 and 18. Will that work? That will not work. 9 times 16. 9 and 16 will work, right? So if I have, so again, 144 is a challenge because there's a lot of factors to it, right? So like if you were to go through and write out all the factors, you'd be sitting there for a while, right? 2 and 72, 3 and 48, 4 and 36, 6 and 24. Okay, so on and so forth until you get to 9 and 16. So there is some sense of being really good with your multiplication tables. Now, I know when I was in grade 3 and 4, we only did multiplication tables up to like 12 times 12, right? So like I personally wouldn't have known 9 times 16 is like right off the top of my head, I wouldn't know that 9 times 16 is 144, right? I mean, I could calculate it, but I don't have that in my muscle memory of multiplication, right? So in that sense, there is some sense of grabbing your calculator and just sort of fiddling until you find one number that works, right? Or a pair of numbers that work. Now, the only thing I also have to be careful about here is the fact that, let me just separate this. So, perfect. The only thing I have to be careful about here is that I have to add up to negative 25. And so 9 and 16 are two numbers that work, but I just have to make them both negative. Okay, so negative 9, negative 16, negative 9 plus negative 16. Okay, so we have 12x squared minus 25x plus 12. So here comes my decomposition, right? So I'm going to split the middle term into 2. So 12x squared minus 9x minus 16x plus 12. So I haven't done anything here, right? I've just kind of rewritten the equation. And now I'm going to group them, right? So I'm going to group the first two terms. Oops. First two terms and the last two terms together. So I noticed that in my first two terms, I can factor out a, well, I can definitely factor out an x. And I notice that both 12 and 9 are divisible by 3. So I can factor out a 3x. And when I do that, I'm going to be left with 4x and minus 3. Okay. Now this second bracket is actually a little bit tricky, right? Again, remember that when you do this common factoring step, your end result should be two brackets that are exactly the same, right? The issue here comes from the fact that I have a negative sign kind of hanging out right here in the middle, and that's gonna cause problems, or some problems, okay? So I would look at that. I would say, okay, well, 16 and 12, both of those are divisible by 4, right? So I'm gonna factor out a 4 because that's what I'm used to. Right? So I'm gonna say plus 4, and when I factor out a 4, I'm going to be left with, so negative 16 divided by 4, that's negative 4, and I still have an x there, and then 12 divided by 4, that's plus 3. Okay. Now, clearly I've made a mistake, right? Because I look at these brackets, 4x minus 3, and I look at this bracket, negative 4x plus 3, and I have a little bit of a problem, right? Again, during this process, those brackets should be identical. If they're not identical, then we've made a mistake somewhere along the way. And in this case, I've made the mistake on purpose, right? I factored out a positive 4. Now, if instead of factoring out a positive 4, if I had factored out a negative 4, let's see how that will change. So if I remove a negative 4 from the last two terms, well, negative 16 divided by negative 4, that gives us positive 4, right? Because a negative divided by another negative gives us a positive, so 4x. And then 12 divided by negative 4, that's a positive divided by a negative, that will give us negative 3. So because I found that my two terms, the signs were switched, all I had to do was just instead factor out a negative number, and then that fixed all of my problems, right? So then I noticed that both of these brackets are identical and everything looks good for the rest of decomposition, right? So that is one place where this can get tricky, is just really keeping track of your signs and making sure that your positives and negatives are all working out. That can be a challenge for this stuff, especially if, I know at the start of the year, we were all a little bit kind of like rusty with our integers, right? Like it was tough to get going with like multiplying two positives together, positive and negative, negative, positive, so on. So that's really, really important here. But then last step, all we do is we just pull out the bracket that's common for both of them. So 4x minus 3, and then whatever is left over, right? So the leftovers, we have 3x minus 4, 3x minus 4, and then we're done. Bit of a harder example, but any questions about that one? Okay, cool. Okay. I think I have one more question, one more example problem to do, and then I have one little trick to show you, and then we're done. Okay, and then you guys can get practice for this on your own. So let's try one more here. So factor 7x squared plus 19x minus 6. So in this case, again, I'm just going to go through the same process. Multiply to get 7 times negative 6. So that's negative 42. And we have to add to get the middle term. So add up to get positive 19. This one's kind of another tricky one because again, I'm not so great with my multiplication of 42, but again, you can just make like a little factor table to kind of help you, right? So I know 1 times 42 will give me 42. 2 times 21 will give me 42. And actually, I look at that and I say, oh, well, 2 times 21 and 19, I can do something there, right? Because 21 minus 2 will give me 19. So it seems like I found a worthy candidate here, 2 and 21. So, but I have to be a little bit careful because I noticed that they have to multiply to give me negative 42. which means that one of these numbers I'll have to make negative, okay? And the one that I force to be negative depends on what I'm adding up to, right? So in this case, I'm adding up to positive 19, which means I have to make the smaller number negative. So 21 take away 2 will give me 19, and that looks good. So positive 21 and negative 2, that will work. That will work out quite nicely. And then I go through with my decomposition, right? So 7x squared plus 19x minus 6. I split up my middle term. 7x squared plus 21x minus 2x minus 6. I do my grouping, right? So I group the first two terms together. And I group the last two terms together. So for my first two terms, I recognize that, well, I have a 7 and a 21. Both of those are divisible by 7. So I can factor out a 7, and both of them have an x. So I can also factor out an x. So 7x, and then I write whatever is left over. So in this case, if I factor out a 7x, I will be left with x plus 3. Now in the second grouping, I have to be a little bit careful, right? Again, I have to really focus on my negatives here, right? Because both 2 and 6 both have a negative sign attached to them. And so I know that 2 and 6 are both divisible by 2, but in order to make sure the rest of my math works out, I'm not just going to factor out a 2, I'm going to factor a negative 2. Okay, so negative 2. And then what's left over is x plus 3. So because I'm removing a negative, it ensures that everything inside the brackets is positive. And then from there, I recognize that we're all good, right? X plus 3 and x plus 3. My two brackets are the same. Okay. And so very last step, I just pull out the bracket that's common to both of them. So x plus 3, and then the remainders, right? So whatever is left over, 7x minus 2. And then I'm done. And then that's it. So that's a few examples of decomposition. How's everyone feeling about this?
Pretty good.
Good. Does anyone have any questions about this?
Nope.
No? Cool. Okay. Excellent. Now I did want to show you guys just one quick trick that I saw. Hello, hi. I did want to show you guys one quick thing that I saw with, this is one of your homework problems for the day, but we're just going to look at the very first part of it. So for question 13 on page 212, I saw this question just like very briefly, just kind of glanced by as I was looking for this problem. And I noticed that there was a negative sign out in front. Now, without that negative sign, this looks like we would use sum and product, right? Because there's no leading coefficient, or I mean, the leading coefficient is -1. But other than that, it looks like a nice candidate for sum and product, right? When we have a situation like this, so like y equals -x squared minus 9x minus 14, one thing that will make your job a lot easier is to first take the negative and factor out a negative, which seems kind of weird, right? Because we're used to factoring out numbers, not signs. The way that you want to think about this is you have like a -1 outside, and then that allows you to just flip every term inside the bracket. And then suddenly everything's positive and a lot nicer to work with, right? From here, we can use sum and product very easily. So there's a lot of little factoring tricks. As we can kind of continue with this, I'll make sure to try to point out any that I see. But there are ways to kind of make this a bit quicker for yourself. And yeah, as I see them, I'll make sure to make you guys aware of them as well. Okay, that was factoring. It's quite a lot. I think I mentioned this yesterday, but factoring is probably the most important concept that you learn in grade 10 math. not only for your grade 11 and grade 12 math courses, if you're planning on taking those, but also like it's massively used in grade 11 and grade 12 physics. You use it often in chemistry, mostly grade 12 chemistry. So this has applications in sciences as well. So even if you're kind of like, okay, I'm taking math, but math is not my passion. I really love chemistry. Chemistry is my passion, or physics is my passion. Then you have to be really good at this stuff for sure, especially in physics. Physics is like all you do is factor. And I would take a bet. I would say like after today's practice, you're probably better at factoring than my grade 11 physics students were this year. So practice, make sure you're really good at it because it will pay dividends later on as you continue with sciences and math, okay? Okay, beyond that, I just wanted to quickly go over the rest of the week just to make sure we're all on the same page here. So I think I mentioned it, where was it here? Yeah, the chapter 4 schedule. So there's a quiz on factoring on May 22nd, which is Friday, okay? So we have 2 days to get really good at this stuff, all right? I realize that's not a ton of time, but it does give you an opportunity. If you feel like you're going through the homework problems from yesterday, yeah, go ahead, Mahmoud.
Is the quiz only going to be on factoring or on everything we talked so far?
Strictly well, like basically what we did yesterday, what we did today, and a little bit about what we're doing tomorrow.
Oh, okay.
Okay, but we'll see about the concepts that we're going to cover tomorrow. If it's too much, I won't put the tomorrow stuff on it, but for sure up to what we've done now, right? So up to decomposition will guaranteed be on the quiz. Okay.
Okay.
Cool.
Yeah.
And I want to say like one other little thing about quizzes and tests. So one thing I'm noticing, not for everyone, most of you are showing a lot of work, which is great. I would say show more work than you think is necessary almost, right? It's much easier for me to give you marks if you show me a lot of work, right? I'd rather give you marks than take marks away. That should be pretty obvious, right? I want to give you credit for the work that you do. But if you don't show me a lot of work, then I can't, my hands are kind of tied. I can't really do too much, right? And so essentially when you're going through quizzes, make sure you justify the solutions that you give me, right? I noticed that on the quizzes that I was marking yesterday. Again, most of you are really good. It's just when you're not justifying your work, my hands are tied and I can't do much. So really make sure you're focused on showing all your steps, especially for this stuff, right? Like I know, I mean, it's pretty simple. If I just factor in type in 7x squared plus 19x minus 6, Wolfram Alpha does it for me. It's not really anything special here, right? Alternative form 7x minus 2x plus 3. It just gives me the answer, right? So I'm not interested in the answer, all right? I don't really care that you get the right answer. I care about all the steps in between, right? So you can have x plus 3 and 7x minus 2, and I would look at that and, I wouldn't really care that you got that. I care about everything in between, okay? So please make sure that you're showing all your steps here, all right? Okay, beyond that, homework for today, I posted 2 worksheets. Factoring 1 is just trinomials, but the leading coefficient is 1. Okay, so quadratics with the leading coefficient of 1. So this page, you do sum and product. Answers are at the bottom. And then factoring 2 is all about factoring via decomposition. So when the leading coefficient is not equal to 1. Okay, and that's it. Done. So I'll put you guys into breakout rooms, and then you guys have lots of opportunity to practice. Okay. Feel free to take a break and then ask me questions whenever they come up. All right.
Just a question. Are we doing the textbook problems or the worksheets, or both?
I would say both. I would say start with the textbook problems, and then like if you feel like you need extra practice, the worksheets are there for you to do. But again, none of this is mandatory. It's just however much you feel until you kind of get the rhythm of this stuff.
Okay.
Okay.